In August 1942, a colonel walked into the U.S. Treasury Department and asked to borrow 14,700 tons of silver. Not gold, silver. The Treasury official blinked. "Young man," he said, "you don't speak of tons of silver. You speak of Troy ounces." The colonel nodded. "Very well, we need 400 million Troy ounces." What followed was the most audacious requisition in American history, and the secret that would end World War II. June 17, 1942. Oak Ridge, Tennessee. Temperature, 94 degrees. The air smelled of red clay dust and fresh-cut timber. In a hastily erected office, Lieutenant Colonel Kenneth Nichols stared at blueprints that represented America's most desperate gamble. The Manhattan Project needed electromagnetic separation to enrich uranium-235, the fuel for an atomic weapon. But there was one catastrophic problem: copper. The calutrons, massive electromagnetic separators designed by Ernest Lawrence at Berkeley, required copper windings to generate magnetic fields powerful enough to separate uranium isotopes. Each unit needed 15,000 tons of copper wire. The project required thousands of these units. Conservative estimates demanded 400,000 tons of copper. But America's copper reserves were exhausted. Every ounce was already allocated to war production: electrical wiring for Liberty ships, shell casings for artillery, communications cables for the Pacific Theater. In 1942 alone, U.S. factories consumed 1.8 million tons of copper. There was none left, not 1 pound. The numbers were brutal. Without electromagnetic separation, uranium enrichment would take decades. Without enriched uranium, no atomic bomb. Without the bomb, the War Department estimated another 2 to 4 years of Pacific island hopping, with projected American casualties exceeding 1 million men in a mainland invasion of Japan. Every month of delay meant 50,000 more American soldiers dead or wounded. The clock was counting corpses. Nichols was 35 years old, a West Point engineering graduate from Ohio who had spent his career building locks and dams. Now he faced an impossible equation: win the technology race against Nazi Germany's atomic program, or watch American cities burn under enemy weapons. German physicists had a 2-year head start. Intelligence reports from occupied Norway showed Nazi scientists stockpiling heavy water. Time was measured in weeks, not months. The initial response from War Production Board officials was predictable: impossible. Copper allocations are frozen. No exceptions. Nichols contacted mining companies. All tapped out. He approached scrap metal dealers, already contracted to the Navy. He petitioned Congress for emergency release of strategic reserves. None existed. Every conventional channel led to the same dead end. The project was dying before it began. On a humid evening in late June, Nichols sat in his office reviewing metallurgical tables. His eyes stopped on atomic number 47, silver. Electrical conductivity, 106% that of copper. Essentially identical electromagnetic properties. Completely interchangeable for high-frequency applications. His hand trembled as he calculated the requirement: 395 million troy ounces, 14,700 tons of refined silver. He knew exactly one place in America that held such quantities: the United States Treasury vaults in West Point, New York. The proposal was insane. The Treasury's silver backed the nation's monetary system. It represented billions of dollars in national reserves. Requesting it for an unproven weapon system, for a project so secret that even Vice President Truman didn't know it existed, violated every protocol. But Nichols understood something fundamental about American pragmatism. When the nation faced existential threat, rules became suggestions. He picked up the telephone. The call would change everything. July 3, 1942, West Point Bullion Depository, 6:47 a.m. The vault doors, 3 feet of reinforced steel, swung open with hydraulic precision. Inside, stacked floor to ceiling, sat 13,540 silver bars, each weighing 1,000 troy ounces. Armed guards watched as Treasury officials signed transfer documents to the War Department marked Emergency War Requisition, Top Secret. The silver was moving to Oak Ridge. The logistics were staggering. Each silver bar required careful documentation. Treasury regulations demanded serial numbers recorded, weights verified to the ounce, purity assayed. Normal processing, 2 weeks per shipment. Timeline allowed, 6 days. Transportation security required armored trains, military escorts, classified routing. The silver left West Point at midnight, arrived in Tennessee before dawn. Continuous convoy, 7 days a week, for 8 weeks straight. At Y-12 plant in Oak Ridge, construction crews worked 18-hour shifts in brutal summer heat. The facility footprint, 825,000 square feet, larger than any factory in America. Workers poured concrete foundations while walls were still being framed. Electrical substations installed while roofs leaked rain. Callutron magnet assemblies arrived before cranes existed to lift them. Everything happened simultaneously because sequential construction meant failure. By September 1942, Y-12 employed 22,482 workers who had no idea what they were building. The silver arrived in ingot form. It needed conversion to wire, continuous, uniform, exceptionally pure. Standard wire drawing facilities couldn't handle the volume or secrecy requirements. Engineers commandeered a factory in Bayway, New Jersey, converting petroleum refining equipment into silver processing machinery. Workers melted 1,000-pound ingots in graphite crucibles, drew the molten silver through tungsten dies, cooled the wire in argon atmosphere to prevent oxidation. Production rate, 500 miles of wire per day. Each spool weighed 750 pounds. The Callutron magnets required winding, 400 turns of silver wire per coil, wound with millimeter precision. Temperature fluctuations caused expansion that could crack insulators. Humidity caused corrosion. Dust particles created shorts. Workers wore surgical gloves, operated in climate-controlled clean rooms, inspected every inch of wire under magnification. 1 floor meant complete rewinding. Quality rejection rate 37%. Each failed coil wasted 2,000 pounds of silver and 6 days of labor. Technical failures compounded pressure. Early Callutrons overheated, melting insulation. Vacuum chambers leaked, contaminating samples. Magnetic field instabilities caused beam drift. Scientists worked through the night recalculating equations, redesigning components, testing modifications. There were no textbooks for this technology. Every solution was invented in real time. Ernest Lawrence slept 4 hours per night, sustained by coffee and desperation. By December 1942, 96 Callutrons were operational. Each one consumed 12,000 kilowatts, enough electricity to power 3,000 homes. Oak Ridge's power consumption exceeded that of Detroit. Tennessee Valley Authority built dedicated substations, but production results were devastating. Enrichment rate of 0.08 grams per day. At that rate, producing enough uranium-235 for a single bomb would take 16 years. The entire project teetered on collapse. Engineers pushed harder, worked longer, accepted no excuses. Failure meant watching Americans die while possessing the knowledge to save them. March 1943, Berlin. German intelligence officer Major Klaus Reinhardt reviewed decoded communications intercepts from Oak Ridge. The reports described power consumption levels that suggested a facility consuming more electricity than entire German cities. His analysis concluded the data was Allied disinformation. No industrial operation requires such energy, he wrote in his report to OKW. Clearly, propaganda designed to intimidate German resolve. His superiors agreed. Nazi strategic doctrine presumed American industrial capability would fragment under pressure, not accelerate. German atomic research followed traditional academic structures, small research groups, limited budgets, university laboratories. By 1943, Germany's uranium enrichment program employed 70 scientists working in 3 separate facilities with minimal coordination. Total electrical allocation, 15 megawatts. Their separation technology relied on thermal diffusion, theoretically sound, practically slow. Estimated timeline to weapons-grade uranium, 1947-1950. German military command considered atomic weapons a post-war development. The Nazis fundamentally misunderstood American operational philosophy. German efficiency meant precision, doing things correctly according to established doctrine. American efficiency meant scale, mobilizing overwhelming resources to force solutions. When German intelligence reported that Oak Ridge employed over 75,000 workers on a single project, analysts dismissed it as impossible. No military program required such workforce concentration. They could not conceive of an operation where traditional limitations, budget, materials, personnel, were simply declared irrelevant. In late 1943, Nazi intelligence finally obtained aerial reconnaissance photographs of Oak Ridge. The images showed a facility sprawling across 59,000 acres with dedicated power plants, railway terminals, and industrial complexes. Photo analysts measured building dimensions suggesting electromagnetic equipment of unprecedented scale. One analyst calculated the magnet sizes and concluded the Americans were attempting electromagnetic uranium separation. His report estimated the silver requirement at approximately 400 million troy ounces. His commanding officer rejected the analysis. The United States Treasury would never authorize such requisition. This is technically feasible but politically impossible. That assumption represented a fatal misunderstanding of American wartime decision-making. The Nazi system valued hierarchical control, where requisitions traveled through bureaucratic channels requiring approvals from multiple ministries. The American system, when confronted with existential threat, simply bypassed obstacles. Treasury Undersecretary Daniel Bell had authorized the silver transfer in a single meeting. His reasoning, if you lose the war, silver reserves become worthless anyway. Take what you need. By mid-1944, German atomic research had produced 2.5 kilograms of enriched uranium, insufficient for any weapon application. Meanwhile, Oak Ridge's production rate exceeded 140 grams per day and accelerating. The gap wasn't technological. German scientists understood the physics. The gap was philosophical. German military planning couldn't imagine the scale of American industrial mobilization. They built programs. America built cities dedicated to single objectives. A captured German scientist, interrogated after VE Day, was shown photographs of Y-12's interior. His response, "This is not a laboratory. This is not even a factory. This is a different category of human enterprise." When told about the Treasury silver, he was silent for several minutes. Then, we never considered that possibility. We assumed normal rules still applied. We were wrong. August 6, 1945, 8:15 a.m., Hiroshima. The B-29 Enola Gay released a 9,700-pound uranium bomb designated Little Boy. The uranium-235 core, 141 pounds of enriched material, represented the cumulative output of Oak Ridge's electromagnetic separation program. 63% of that uranium passed through silver coils, wound in Tennessee factories. The explosion yielded 15 kilotons. Estimated casualties, 80,000 immediate deaths, 70,000 more from radiation within 5 years. 3 days later, Nagasaki. August 15th, Japan surrendered. The war ended. The silver saved the bomb. The bomb saved millions. War Department projections estimated Operation Downfall, the planned invasion of Japan, would cost 400,000 to 800,000 American casualties and 5 to 10 million Japanese deaths from combat, starvation, and disease over 18 months of fighting. Those deaths didn't happen. The mathematics of nuclear deterrence are brutal but undeniable. The atomic bomb's demonstration convinced Japanese leadership that continued resistance meant national extinction. Strategic calculations replaced ideological commitment. Surrender followed inevitably. Post-war, the silver was returned. Between 1945 and 1970, Treasury auditors verified the return of 489,000 troy ounces, 99.97% of the borrowed amount. The missing zero, Hydro 3%, approximately 120,000 ounces, remained embedded in equipment, lost to industrial processes, or disappeared into the chaotic final months of wartime accounting. Treasury officials considered it acceptable loss. The silver resumed its monetary function as if the greatest industrial requisition in American history had never occurred. The human cost of the Manhattan Project extended beyond Hiroshima and Nagasaki. Oak Ridge workers absorbed radiation exposure in facilities where safety protocols were invented concurrently with the work. Medical monitoring was primitive. Dosimeters were rare. Long-term health effects emerged decades later. Elevated cancer rates, reproductive complications, genetic damage. Many workers never knew what they had built. Security clearances prevented disclosure until 1946. Some died never learning their sacrifice helped end history's deadliest war. The institutional legacy transformed American scientific-industrial collaboration. Before 1942, major research occurred in universities with small budgets and academic timelines. The Manhattan Project demonstrated that government-funded, mission-focused research could achieve in 3 years what traditional methods might never accomplish. This model became the template for post-war American innovation. NASA's Moon Program, DARPA's Internet development, the Human Genome Project. The pattern established at Oak Ridge, impossible deadline, unlimited resources, accept no failure, became distinctly American. Colonel Nichols, promoted to general, reflected in 1987 interview, "We borrowed the nation's silver reserves to build coils for machines that didn't exist, to enrich material whose properties we didn't fully understand, to create weapons we hoped would never be used again." Hindsight suggests recklessness. But in 1942, with American soldiers dying daily and Nazi Germany pursuing identical weapons, caution meant surrender. We chose audacity instead. The Y-12 facility still operates in Oak Ridge, now processing materials for nuclear stockpile maintenance. The original Calutrons were dismantled in 1945, their silver reclaimed. But the magnet foundations remain, buried under newer construction, concrete monuments. To the moment when American engineers asked the impossible, the Treasury said yes, and 14,700 tons of silver became the secret catalyst that ended World War II. The story proves something fundamental about American character. When confronted with existential crisis, the nation doesn't ask if something is possible. It asks what it will take, and then builds it anyway.